Alright, so gas and fire detectors. These are detectors that, as the name suggests, they detect for the presence of certain types of gases in the air, as well as detectors that senses the presence of fire. So let's go right into it. There we go. So detection devices, we have the fire, the gas detectors. The dust detector is also um, it's related to the gas detector, except it focuses more on the dust particles. Okay, so fire detector and gas detectors. Let's start with gas detectors. Okay, let's start here. We have two kinds of gas detectors. We have one that measures that detects the presence of flammable gas in the air, and another that detects the presence of toxic gases in the air. Okay, so let's starting with flammable gas detectors. We have catalytic gas detectors. Okay, so what catalytic gas detectors do is that um, they measure the heat. They measure the heat output from the oxidization of the flammable gases, and once that heat is detected, the alarm is tripped, meaning there's flammable gas in the air. Another is using infrared, because flammable gas, they have their own certain properties when it comes to absorbing infrared energy from the sensor. So the absorption and the interaction of the gas and the infrared light emitted is detected by the gas detector, and once that happens, the alarm is tripped. So we also have two kinds of infrared gas detectors. We have the one that detects within its own chamber, and there's also the open path that looks at the infrared energy interaction of the infrared light and the flammable gas from a much further distance. Okay, so those are the two types of flammable gas detectors. We also have toxic gas detectors. We have the electrochemical cell and the semiconductor type. Okay, so these two measure the presence of H2S, which is hydrogen sulfide gas. Okay, hydrogen sulfide gas. So as for the electrochemical cell, um, there's a cell inside it that reacts to the presence of hydrogen sulfide, and once the reaction occurs, that's when the gas detector trips and the alarm is activated. Another is the semiconductor type, wherein there's a crystal. Okay, there's a crystal inside there's a crystal inside the circuit, which absorbs hydrogen sulfide molecules from the atmosphere, and once it does, the resistance value of that crystal changes, and once the resistance value changes and the voltage input is fixed, that means the current flow through that crystal goes down. And once that happens, the semiconductor, once the resistance goes up and the current flow goes down, the alarm is then tripped, meaning there's a presence of H2S, which is a toxic gas in the air. So now let's move on to fire detectors: smoke, heat, and flame. So smoke detectors, they look at the presence of smoke in the atmosphere, which is the byproduct of a fire. We have ionization and photoelectric type. So the ionization type of smoke detectors, they have an ionized chamber, and let's put that in. Here we are. Okay, so we have an ionization chamber where the air is ionized by this americium foil. So if there is smoke, smoke particles will find its way from the atmosphere towards the ionization chamber. The aerosol particles then get attracted to the ionized particles within the chamber, and the once that happens, the resistance goes up, and in much the same manner, once the resistance goes up, the current flow goes down, and the alarm is tripped, meaning there is smoke in the air. Another is with the photoelectric type of smoke detectors.
Wednesday, sir.
So, how that works is
Yes, sir.
right here. How the photoelectric type works is right here. We have a light transmitter. It doesn't necessarily have to be visible light. It can be, for example, infrared light. And then we have a resistor, a receiver rather, right here at an off angle. So normally, if there are no smoke particles, the transmitter just transmits the energy straight across and not to the receiver. And if there are smoke particles present, that bounces right, that reflects some of the transmitted energy to the receiver. And once that happens, as you guessed it, the alarm trips, and it means that there's smoke in there. If there's smoke, there's fire. Another way to measure is with heat, another byproduct of fire. So if fire creates smoke, fire also creates heat. We all know that. So there are two kinds of heat detectors. Okay, there are two kinds. There's the linear and the rate of change. So linear heat detectors, they they trip the alarm once a certain temperature limit gets breached. For example, you set it at 200 degrees Celsius. Once the temperature is reached, the alarm gets tripped. Another is the rate of change, which does not look at the fixed value of the temperature itself, but rather how fast is the temperature changing. Okay, how fast is the temperature rising? So this would best work if you have a linear type as a backup in case the flame is changing the temperature in a certain room too slowly for it to be detected. You would want a linear as a backup. Okay, but then uh, as for linear, in very hot environments, in places where that's expected to go hot, it would not be ideal as it would always get tripped. Okay, so next we have flame detectors. If you have detectors that look for the byproduct, which is smoke and heat, we also have detectors that look at the presence of the flame itself. So there's UV and IR sensor, which looks at ultraviolet, the ultraviolet and the infrared radiation emitted by the fire itself, as well as the spark and ember detector, which looks at the presence of ember particles in the air from as is present when there is fire. Okay, so we have three kinds of fire detectors. When do we use each? So most commonly we use smoke detectors because smoke is not always present everywhere. So you don't expect to have smoke in a classroom or in a library. but you're expected to have smoke when you're in the kitchen, when there's cooking and when there is steam, there is smoke. So you also have other types, which is the heat detector that looks at the temperature within the room. If the temperature goes too hot, it means there's a fire that's out of control. Okay, so for example, in the kitchen or in a plant where it's expected to have smoke and flames in order to, for the plant or the kitchen to operate, there's always going to be smoke and flame. So you would not want to have smoke and flame detectors when you're in those kinds of environments. You would want heat detectors. Okay, and in those cases, you would have to choose between the linear and the rate of change. And if you're going to choose the rate of change, you would want a linear as your backup. Okay, so that would be all for gas and fire detectors.